screen. Okay, so we're going to talk about kinetic energy, and this is not kinetic energy, kinetic. It's the energy an object possesses because of its motion. Now, in order for an object to have kinetic energy, work has to be done on it. Remember, energy is the ability to do work. So if something has kinetic energy, it has the ability to do some work, all right? And the reverse is true. If you do a certain amount of work on an object, that object will now have kinetic energy. You're going to speed it up. So we're going to talk about an object like we'll just use an example of a box because that's the most common thing we can use. And we're going to put a force on it, all right? And we're going to move it through some distance, d, right? Okay? And so the box will eventually end up over here. And as you know, if there's no friction, this box will accelerate as it goes across from that first point to the second point, right? So we'll say at point 1, it's not moving. And over here, it is moving. Now, the kinetic energy that it has at this second point will be equal to the force times the distance, because that is the amount of work it takes to move it from there to there. It's just as simple as that. How we got to get, we're going to put this in terms of simply mass and velocity. So how the heck do we do that? Well, if we go, I'm doing this, if we have some mass, all right, what's the acceleration of this object? We know that acceleration by Newton's second law is equal to F net divided by m. So we can actually take F net, and F net is just the F that's applied here, and just replace it with ma. So I can take this F out. I'm going to replace it with ma. It's mad. Okay. From the fourth equation, the kinematics equation, we know that final velocity squared is equal to initial velocity squared plus 2AD, right? But what is our initial velocity in this scenario? It's 0, so we're going to get rid of it. All right? Notice up here, if we can change this to be AD equals to KE divided by M, right? Everyone following me? This is just pure algebra right now. I'm going to replace this AD with KE over M. Okay? So let me just clean this up a little bit. So it's going to become 2, I don't want that color. It's going to become 2KE over M. Now I'm going to isolate the KE. So I'm going to multiply both sides by M and divide by 2. Multiply by M, divide by 2. These cancel out. And we end up with the equation that the kinetic energy that the object has when it's moved through a distance by a force is equal to 1/2 m v squared. So that is your kinetic energy that you would have. All right? And that is on your reference tables. It is equation, I don't have it open. I should have it open. Physics, reference tables. It's equation number 20. So the equations, the problems on the handout I just gave you, I'm going to be posting that on Google Classroom for you to do those problems.